sampling distributions, knowing how to work with sampling distributions and what they are. So let's look at the sampling distribution of the sample mean of a specific sample size, n. The mean of a sampling distribution is just the mean of the population. Now, this can always be calculated, even if we're not talking about our sampling distribution being normal. We always know that the sampling distribution, the mean of our sampling distribution of size n, is just the mean of the population. The standard deviation of a sampling distribution is just the standard deviation of our population divided by the square root of n. So again, even if the conditions for normality are not met, we can still talk about what its mean and standard deviation is for a sampling distribution. We just can't say that the sampling distribution is normal. So when can we do that? Well, the shape of the sampling distribution, if the population that the sample came from is normal, then all the sampling distributions will be normal no matter what the sample size. But if we don't know anything about the shape of the population, or we know it's not normal, then in order to evoke the central limit theorem, and remember what the central limit theorem said, is that the shape of our sampling distribution is approximately normal if our sample size is large enough. Well, in our class, if our sample size is 30 or more, we can assume that the sampling distribution is approximately normally distributed. Well, you're also going to have to know, once we know that we have a sampling distribution that's approximately normal, you will have problems computing probabilities based on the sampling distribution of the sample mean. So they'll look like Chapter 3 problems, but they'll be the probability that the mean of samples of size n take on certain values, less than 30 or more than 30 or something to that effect. So knowing how to calculate those. You'll have to know inferential techniques based on the sampling distribution when the conditions are met. In other words, estimation and significance tests, or hypothesis tests. So if we have a sampling distribution that's approximately normal, all the conditions are met, simple random sample and its normality. If we're trying to estimate the value of a parameter, in other words, making a confidence interval, remember that's always a statistic plus or minus the margin of error, where the margin of error is the critical value times the standard error. If sigma is known, the way that we do this is we take the sample mean, we add and subtract to it the margin of error. So we take our critical value times the standard error, which is sigma over the square root of n. But if we don't know sigma, then our our confidence interval, we're no longer using table A, since we have to estimate S, we're in the student t distributions, and which distribution we go to depends on our sample size. We need to know what the degree of freedom is. So our way that we find or we calculate our confidence intervals, we take the sample mean plus or minus this critical value, which now we need two pieces of information to find, the confidence level and the sample size, because degrees of freedom are n minus 1. We take that critical value and multiply it by the standard error, which is now s over the square root of n. We're going to take that margin of error and add and subtract it from our mean. Now, I forgot to talk about the sample size. If we know what sigma is, if sigma is known, that is, we can find the sample size. In other words, we can determine the sample size needed so that a specific margin of error is observed at a specified confidence level. And the way we find this sample size is we use this formula, n equal, and in parentheses, we're going to square this quantity, our critical value times our standard deviation, population standard deviation, divided by, oh, not 3, but I meant to put m on there. Sorry about that. Hold on, let me change it. Divided by that margin of error that is being specified. So we can find sample sizes this way, only when we know what sigma is. So let's look at significance tests. Well, if sigma is known, we can find our test statistic as x bar minus mu naught over the standard error, which is sigma divided by the square root of n. And if sigma is unknown, the test statistic is going to be t naught, because we have to go to the student t distribution. So it's just x bar minus mu naught s over the square root of n. And remember, we're going to use these test statistics to find our p-value, how far out we are in the tail end with the probability of making a type 1 error. And if our p-value is less than alpha, we reject or do not reject the null hypothesis. So now let's look at the sampling distribution of the sample proportions of particular sample sizes, let's say n. The mean will always be the proportion of the population. So mu sub p hat equal p. Again, we can calculate this even not knowing the shape of the distribution. We can always say what the mean and standard deviation is. We just won't necessarily be able to say that it can be approximately normal unless the conditions are met. And the standard deviation is the square root of p, 1 minus p over n, or the standard error, standard deviation of our sampling distribution, or we could call it the standard error. Now, you would have to calculate these because you can do that particular quantity. So you will have to calculate standard errors except for 2 sample problems where we'll give you those. 2 sample mean, independent, and 2 sample proportion. And I'll say that one more time, but just to let you know. Now, the shape of this distribution, we can say that this proportion is approximately normal if n times p times 1 minus p is greater than or equal to 10. That's a conservative. Now, what your book says, if you just have n times p is greater than or equal to 10, in other words, if the number of successes and the number of failures is and the number, that should be and. That's very important. Very, very important that the number of successes and failures be 10 or more. If you do the n times p times 1 minus p, if that's true, then the number of successes and failures will be more than 10. It will work. So if that's true, then you can say that our sampling distribution of the sample proportion is approximately normal, and then we're back to using Table A. So we can do our inferential techniques based on the sampling distribution when the conditions are met, simple random samples, and normality. So let's look at the estimation of our population parameter p. If we want to estimate that, we'll use our p hat. So the confidence interval for this is using our p hat plus or minus our critical value, which is determined by our confidence level, times the standard error. But as you can see, the standard error has to change a little bit. I have to estimate p with the p hat that I have. Now, in these problems, I can also do sample sizes. Again, we can determine the sample size needed so that a specific margin of error is observed at a specific confidence level. And this would be it. N equals, our sample size would equal p times 1 minus p times our critical value divided by the margin of error squared. Now, if no prior estimate of p is known, then we're going to then we'll use it. I mean, if a prior estimate is known, use it. Put it in that formula. If a prior estimate is not known, then just use the value p equal 0.5, 50%. Now, for tests of significance, to find our test statistic, again, we'll always be in Table A when we're dealing with proportions. It's just p hat minus p naught, the value of our proportion in the null hypothesis distribution, divided by the standard error of our null hypothesis distribution. So we'll use that value in the null hypothesis in our standard error, p naught times 1 minus p naught over n, and take the square root of that quotient. Now, inferential techniques for the 2 sample problems, and I'm going to have some PowerPoints I'm going to put up that Professor Davis made up that are just lovely, to show, to go over conditions met and things like that. But I'm just cursory going through it. For 2 sample problems, either means and proportions, we'll give you the standard error for the 2 sample problems where it's independent and for the 2 sample proportion problems. Now, for the 2 sample dependent, we'll give you the standard deviation of those differences, and you'll be able to find the standard error by s divided by the square root of n. But for the independent, it's a little bit more complicated. It just would take you so long to do it for the final that we'll give it to you. You will have to be able to calculate the pooled proportion for the 2 sample proportion problems for the test of significance. Remember that that's p hat is x1 plus x2 over n1 plus n2. But again, we're not going to make you use that pooled proportion to find the standard error or the test statistic for that problem. We'll still give that to you because it still is very, very complicated. And then, so you will have to do confidence intervals, and now remember, you're going to have to do confidence intervals and do test of significance for these, but we'll give you that standard error, the interpretations and all that, that the conditions are met, so study those conditions. Then the last thing that we worked on in this class was goodness of fit tests. So I'm going to pull up the PowerPoints in the next installment of our review and go over some of the conditions that need to be met